Hello class, this is CSE-4410, Sections 1 and 2, Chapter 3, Spring 2025. So we're going to continue with our first-person shooter that we created last week. So far we have a scene in which our player can wander around, look around, but there's nothing to do. That doesn't really make for a fun video game if there's nothing to do in the video game. So now we're going to give the player something to do. That is to have enemies that the player can shoot at, but also the enemies can also retaliate at the player by shooting at the player. So we're going to have some enemies that can wander around, shoot at the player can shoot back, but of course we have to begin by giving the player the ability to shoot at stuff. So we're going to do that using a Raycast. Typically in shooting games, shooting is achieved using a Raycast. So if you can imagine a gun, or I guess more appropriate, imagine a laser sight or a laser pointer. A beam goes from the laser point and it hits some object. Whatever object was hit, we can determine what that object was, and then, based on what it was, we can do appropriate calculations to it. If this was an enemy, for example, we can simply decrement health points from the enemy. For our game, we want a ray to begin at the camera. A beam fires from the camera, hits something, and then we're going to figure out what that object that was hit. So we're going to use a few new methods, but to begin, let's write a brand new script called RayShooter to be attached to the camera. So these are all our previous scripts from before. We need a new one. So let's create a brand new script, call this RayShooter. The RayShooter script the RayShooter script should be attached to the camera. So just drag and drop that onto the camera like so. Open the script in your choice of IDE. We're going to begin with writing a private field that stores a reference to the camera. There we go. So you might see this a lot in Unity coding, where the data type is capital letter keyword here, and the variable is the same keyword, but the first letter is lowercase. You see this a lot, and it might be a little bit confusing. It confused even me at first. Basically, capital anything is oftentimes a data type or data structure or something like that. And lowercase is basically a variable. You'll see this a lot. Okay, so now we have a variable that is going to store a reference to the camera. That means we're going to need to use a get component. So we're going to say cam equals get component. In angle brackets, we're going to say camera, and then left right parenthesis. So the moment the game starts, we're going to get a reference to the camera. Okay, so now we have a reference to the camera. When the player left clicks, perform a Raycast. So if input.getMask button down 0, calculate the center of the screen. So we need to calculate the center of the screen because, again, we are performing a Raycast from the camera, And it's usually going to be in the middle of the screen. So we're going to store this in a vector tree because the upcoming method requires it to be as a vector tree. Point equals new vector tree. We calculate the middle of the screen by saying cam.pixel width divided by 2. And then cam.pixel height divided by 2. And then we pass, then 0 should be the third argument here. So cam.pixel width divided by 2, cam.pixel height divided by 2, and then 0. So now we have a point that represents the middle of the screen. We're gonna pass in that point into a method called cam.screenPointToRay. So we're gonna create a ray. Create a ray whose starting point is the middle of the screen. So capital R ray, lowercase r ray. Capital R ray, that's the data type. Well, it's a struct. But lowercase r ray, that is just an instance of this ray data structure. So ray equals cam.screenPointToRay. Cam.screenPointToRay, and we pass in the starting point of our ray. There we go. Next, we're gonna create a Raycast object. So we're gonna create a Raycast object called hit. So the data type is Raycast hit. The variable is called hit. We're gonna pass that into a Raycast method. But this Raycast method is also gonna return true or false based on whether we hit anything. So here's how it's gonna work. If physics.raycast, we pass in our ray, but we also pass in this. Currently there's nothing assigned to this, but we will get something out of it. So out, hit. If we hit something, for now let's just print out the coordinates of what we hit. So debug.log hit object. Oh, we can just say hit. And then we're gonna add on to that the coordinates of what we hit. So that is hit.point. So this point is not to be mistaken for this point. This point is just the beginning of the ray. This point is actually the end of the path, if you think of it as a starting point from the camera, and the ending point being whatever we just hit. Okay, so once again, all of this code is in the RayShooter script. Pause the video if you wanna compare your code to mine. Okay, this RayShooter script should be attached to the camera. Let's just double check to make sure it's attached to the camera. Yes, it is, but I have two instances for some reason. Oh well, I'll just remove one component. But we need one RayShooter script. Oh, by the way, if you double click on any one of these objects in the hierarchy, the scene view will just go straight to that object. So in case you're ever lost in your own scene, don't worry. Just double click an object in your scene and you'll just move straight to that object. So here we have the player. We're gonna shots fired. I'm clicking. Wherever I hit, is printed at the console. So if I hit the wall, if you look closely at the bar down here, it tells me where exactly I hit. If I try to hit something where there's nothing, if I try to shoot the sky, nothing happens because there's nothing to hit up there. There are no game objects to hit, therefore nothing gets printed in the console. Pretty self-explanatory, right? Okay, but wouldn't it be nice to get some sort of visual indication as to what's going on? How about a crosshair to indicate where we're shooting from? Let's do that really quick, okay? Okay, so we're not gonna start with the crosshair yet. Let's actually have the player fire bullets first. So we're gonna begin with a visual indicator of where in the scene was hit, because the player doesn't see the console. We, as the developers, see the console, but the player usually does not. So of course, wouldn't we like to get like little pellets stuck in whatever game objects we hit? So let's begin writing that. This is section 3.1.3 as outlined here. So typically in a first-person shooter, whatever object we fire typically has a little bullet hole texture placed on it. We're just gonna have a little game object be used for that. So we're gonna modify our script so that if the player left clicks the mouse and a Raycast successfully hits something, we're gonna place a little sphere at that location. That sphere, however, should only last a short amount of time, say 1 second. To accomplish our sphere disappearing after 1 second, we need to implement what is called a coroutine. When you call a function in a program, the program waits until that function finishes. With the coroutine, it's a lot different. We are now having a task that runs in the background at the same time as some other functions. So this is a way of having concurrent activities happening in our game. So we place down a sphere, and then immediately you can place down another sphere, and then immediately after that we place down another sphere, and they all have countdowns that start at different times, and they're all taking down independently of one another. So we're going to add a method to our RayShooter script. We're going to call that sphere indicator. So let me just exit out that slideshow, and first we begin with a coroutine. Coroutines are special methods that have the return type of enumerator. Place down a sphere at a location, which then disappears after 1 second. So the data type, as I said, is the return type is, as I said, enumerator. The sphere indicator method has one single argument of type vector3. That's just a position of where we want the sphere to be. So we're gonna create a new sphere game object. So game object sphere equals capital G game object dot create primitive, and then in parentheses we're gonna pass in primitive type.sphere. We're gonna place the sphere at the position that we had just passed in. So sphere dot transform dot position equals pause. Not to be confused with point of sale, and definitely not to be confused with pizza. Alright, now we need to wait 1 second. So for us to wait 1 second, we say yield return new, wait for seconds, 1, and then we destroy the sphere. Okay, so now we have a coroutine. It's not gonna do anything until we call it. Nowhere in this code is our sphere indicator being called. So let's call it in here. We can leave our debug code here, but we want to call our coroutine here. Remember, this sequence of step is player presses the left mouse button and we perform a raycast. If the raycast hits something, we not only print out where the object was hit, but we're also going to place down a sphere at that location. So and that right there is not how you're supposed to call sphere indicator. Because this is a coroutine, we need to pass this function call. We need to pass this into another method entirely. That is start coroutine. There we go. So we start our sphere indicator coroutine. We pass in the location of where that object was hit by our raycast. We place down a sphere at that location. Alright, let's try it out. And now we can see where exactly we are hitting. And I guess another odd bug we have in store is the fact that when a sphere hits another sphere, it just places that object down. So I guess an advanced thing we can do is when we perform our raycast, we ignore any sphere that we had already placed down. That might be a bit of an advanced topic, so for now let's just ignore it for now and hope that this bug doesn't come back to haunt us. Again, we can fix it if you want to, but let's move on to our next step, and that is, hey, we have the cursor. You would think the cursor is where the ball is being placed, but no, remember, it is at the center of the screen. So what we need to do is a few more steps to make it clear that we are firing from the center of the screen. So let's fix that up and add a few more lines of code. First, we're gonna hide the cursor. Hide the cursor, so we're gonna add a few lines of code to here. We're gonna say cursor.lockState equals cursor.lockMode.lock. Then we're gonna say cursor.visible equals false. So what this does is, if we now play our game, the cursor is hidden from view, so you can't see where the cursor is anymore. But what this also does is make it so that the cursor is locked to the game view. which may or may not be a good thing depending on what kind of game you have. Well, in the case of a first-person shooter, it means that if you move your mouse really far, it will never leave the confines of your game view. But if you want to unlock the cursor, you need to press the escape key for that. So that's something just to keep in mind. If you have the cursor locked to the game view, you must press escape to unlock it so your cursor is free to, well, leave the game view and you can click on other stuff. But of course, you want to hide the cursor so it doesn't become a distraction for when you are firing at stuff. Once again, if you want to unlock it, you gotta press escape, and now our cursor is free to move outside the game view and we can stop the game. Let's add a crosshair. For that, we need another method, and that is called OnGUI. So we're gonna draw a little crosshair on the screen. So there is one other way we can do this, but we would need to use a canvas object for that. This one's a little bit quicker and requires no editing in the game world itself. What I mean is this crosshair is drawn only using code. So it's just a little character placed on the screen using text. So int size equals 12. We are going to place the crosshair in the middle of the screen, so we need coordinates for that. And then we are going to draw a label on the screen using a method called GUI.label, and we need to pass in a rectangle into this method, and then we're gonna pass in a string of text that's gonna represent our crosshair. So new rect, we pass in a rectangle, and then we pass in a string of text. We're just going to use a plus for now. The slides has us use a asterisk, but I think a plus sign is more typical of a crosshair character. Anyway, if I play now, we should see a little... Okay, this is really small because I guess my screen is so huge, but if I zoom really far in, you'll see a little speck here. That's my crosshair. So it would be a matter of changing the scale on that to make sure we can actually see the thing. So I'm gonna check the code a little bit just for the sake of demonstration. So wait here. Okay, so after some debugging, I tried to get the this size here is actually a font size for the text that we're placing in a rectangle object. I tried to adjust that, but the problem is it's like way in the wrong position right now. So I don't know what's going on over there, but it means that our crosshair isn't as accurate as we'd like it to be. So I think for now I'm just gonna put it back to the default, to the original size of like, I'll just make it 24, and hope it's centered enough for our next step. Okay, that is sufficiently centered. So maybe that one would, so maybe this is better. It's a little nub on the screen, but I think it's noticeable enough as long as you're not staring at a perfectly white wall. that should be passable as a crosshair, as small as it is. There is another way you can there's another way you can place a crosshair, but that would require us to use a canvas object, which is a little bit later in the course, by the way. Okay, so now, here's the fun part. If we shoot an object, we want the object that was hit to do something as a result. So, let's look into that. Alright, so I've created a brand new game object. It's a cube. I call it enemy. What I want to do now is create a brand new script called ReactiveTarget. I'm gonna place that at top. I'm gonna attach that to the cube. I'm gonna click on the cube and make sure the ReactiveTarget script is attached. Oh, not part of the instructions, but let's have a little bit of fun here. Let's create a new thing called a material. So right click in this empty space, not in the scripts folder, rather it should be in the assets folder. Let's create a brand new material. Let's call it enemy material. We'll call this enemy material, and in the albedo field in the inspector, let's change that to be a little bit orange. And then we're going to attach this material onto our cube. That way, this is just to tell it apart from this spinning cube over here. So with the ReactiveTarget script attached to the enemy, let's do this now. We're going to go back to our Raycast code here, and we're gonna go back to here. We're gonna modify our code here. So we actually need to write a few more lines of code before we start writing if. We say game object hit object, because we can get a reference to the game object that was hit. Capital G game object, by the way, is just a, think of that, that's just a data type for things in the Unity scene. So this is the base class for all entities in Unity scenes. Capital G game object are just the class. Lowercase game object could be like any game object in the scene. But here it's just a hit object. So we have a hit object that's going to be the game object that was hit by our array. So we say on the right hand side here, hit.transform dot lowercase g game object. So lowercase g game object is just in this case, it is a property of this transform that is part of our hit variable here. That's just a property. Whereas capital G game object, that is a data type. Yeah, that's one other thing that even confused me at the beginning, disambiguating between capital G game object and lowercase g game object. Here, this game object is just a property. And capital G game object here, it shows up as this cyan color in Visual Studio. That is a data type. Okay, now we have a reference to the game object that was hit by our Raycast. What we can then do is use getComponent to see whether that thing we hit had a ReactiveTarget script attached to it. So our reactive target script that we had written earlier, that we had attached to the enemy cube here, we can reference that in our code by saying hit object dot get component reactive target. And now, what reactive target does is it's going to return a reference to the reactive target script that was attached to the game object that we hit with our Raycast, that we did when we clicked the left mouse button. And get component is always going to return something, even if it's null. If it's null, that means no such component was attached to our game object. But let's say we did get component and we have a non-null reference for that. That means reactive target was attached to the object that we hit. In that case, if target does not equal null, debug to that log target hit. Else start coroutine our sphere indicator code. I'll just copy paste that here. There we go. Let me just make sure everything is indented properly. There we go. So, let's try it out. We have reactive target. We have a reactive target script on our enemy. Let's see what happens. If we click if we click anywhere in the scene, it places down a sphere. If we instead hit the enemy cube over here, this red one, target hit. And once again, if I want to unlock the cursor from the game view, I need to press escape. But yeah, we can see that we hit the target. Clear, and let's see our next step. Alright, so now we have a reference to the reactive target script that was attached to the enemy object here. What we can then do is we can write a method in here called ReactiveTarget. This must be a public method so that any other script can call it. Let's say it's public void reactive hit, and currently it doesn't do anything. At the same time, what we want to do is in our RayShooter, we want to call that method that we just wrote in reactive target. So in here, if target does not equal null, say target dot reactive hit. So we have a reactive hit method in our reactive target script that is now being called in our RayShooter script if what we hit had a reactive target component attached to it. When we call this method, we want to start a coroutine that is going to be the death animation of this object. So here's how it works. When reactive hit is called, it's gonna start another coroutine that plays out the enemy's death animation. Let's start with the death animation. So the death animation coroutine is public I enumerator, not enumerable, I enumerator die. Because when it's called, this game object is gonna die. Rotate the game object as if it fell over. I can say transform.rotate, but what technically works is this .transform.rotate. If you're doing this in Visual Studio, it might say you don't have to add this keyword. So transform.rotate or this .transform.rotate. This technically works too, but you can simplify the name. So this .transform.rotate, we're gonna pass in as Euler angles. Remember from last week we talked about the rotate method. We're gonna rotate it about the x-axis, so it's gonna fall over to its side. We're gonna pass in negative 75 degrees to rotate it backwards. So it's like falling over to the side. Well, falling backwards, I should say. And then we can have 0 and 0 for our other two angles, and there we go. We're gonna wait 1.5 seconds. Then we do that by saying yield, return, new, wait for seconds, 1.5 f, and then we're gonna despawn the game object itself. Destroy this game object. If you just write out game object by itself, in this context, it's just the game object being... Okay, if you just write game object by itself in this context here, this is the game object to which the ReactiveTarget script was attached to. So, if this script is attached to the enemy here, if I say destroy game object, that's going to destroy the game object that the script was attached to. So, when the enemy is hit, it's going to perform a death animation and then destroy itself. It's gonna die. Let's try it out. Yep. You saw that, right? Maybe I have to restart the game. So anyway, if I click anywhere in the scene, it's gonna place down an object. But if I click the enemy, it's gonna fall over it and die. Anyway, I guess it would be more obvious that it fell over and died if I scaled the y value for scale, not to be 1 but 2. What this does is makes the enemy cube taller. Let's hit him. Damn. Fell over and died. There we go. Okay, so that is part 1 to this whole thing. Let's proceed to part 2. So part 2 is a bit more interesting. This is where we start to make our enemy a bit smart. We're gonna implement a simple AI. I feel like it should, I guess this is just my own opinion regarding AI, but we think of AI as just being like an artificial neural network or something like that, ChatGPT and the like. When the truth is AI has been around for decades already. Even something as simple as the thermostat controls, that is an AI in a way. That's one of the simplest AI you can make. And the earliest video games also had some rudimentary methods that created an AI appropriate for a video game boss, for example. Or in this case, we're gonna write an AI that works as follows. The enemy is going to move forward a little bit, because right now, if our enemy is just standing still, it's just doing nothing, we call that boring. The enemy moves forward a little bit, it performs a Raycast to look for obstacles, and then it's gonna turn around. And then it's gonna repeat step 1. So, move forward, perform a raycast to look for obstacles. If it finds an obstacle, turn around, and then repeat. So, in every frame, the AI character is going to perform a raycast. When we perform a raycast, when we were performing the raycast for our player to shoot projectiles, that was a raycast like that. That is appropriate because we just need a single point that indicates this is where we hit. But if we used a raycast for the enemy, the problem is this. This raycast is an infinitely thin line. The problem is it might see an obstacle, but it might just miss an even closer obstacle. So we want our raycast to have a thickness, so instead of a single infinitely thin line, it's gonna be a solid cylinder of raycasts. And if that cylinder intersects with something, that means there is an obstacle in the way. The AI says, I'm gonna turn around and move somewhere else. So, what we want to do is not use Raycast, but rather SphereCast. So, we're going to create a brand new script called WanderingAI. This wandering script AI goes to the player. So we're going to drag and drop it onto our player. Check it out. We have a ReactiveTarget script and a WanderingAI script. And they are both independent of one another. So, let's begin editing this script now. We need a few fields. The first field is how fast the object should be moving. Let's set the default speed to 3. Okay, so that is how fast the enemy is going to move. The next field is going to be how far the enemy is going to look for obstacles. So, make sure your keywords are spelled correctly, okay? And now, we won't need the start method here, but we will be using the update method because we're going to move the enemy a little bit every frame. So, here's how it's going to do. Move forward. And to move forward, that is simply transform dot translate 0, 0. Remember that. Okay, so something to keep in mind about X, Y, and Z. X is for left and right. Okay, so the X-axis is left and right for a game object. The Y-axis is up and down, and the Z-axis is forward and backward. So we want to move the cube forward. That means we need to move it along the positive Z direction. So we're gonna say speed times time dot delta times n. So we've moved our cube a little bit forward. We're going to create a ray in the same direction as the game object's direction of movement. So ray equals new ray. And then we're going to pass in transform dot position, transform dot forward. So, transform.position, that is the starting point of our ray. Transform.forward is the direction in which you're looking at. Now we need Raycast hit. Remember, hit is just a hit here is just a data container. It doesn't contain anything until we pass it into physics.raycast, or in this case, SphereCast. So we're gonna perform a SphereCast. If physics.SphereCast ray 0.75f. So that 0.75f, that is a radius of our SphereCast. That is the thickness of the cylinder that we're casting. So instead of a ray, think of it as like a cylinder. That is the radius of our cylinder. But we are not done yet. We need to say out hit, and then if the ray had hit something, turn around by some random angle. But only if the distance from that object that we hit is less than our obstacle range. So if it's too close to us, turn around some random angle. If hit dot distance is less than obstacle range, we're gonna randomize an angle. So random dot range negative 110 110. So we're gonna create a random. We're gonna generate a random angle, and we're gonna say transform dot rotate, and then we're gonna. This is going to be a rotation about the y-axis. So 0 angle 0. There we go. So what this should do now is, if we just play the game, that cube should move around now. Hey, it's moving away now. Oh, you saw that, right? It's smart enough to just... Well, it's kind of dumb in the sense that it's doing random movements, but it's smart enough to avoid obstacles. And I can just hit. But you see how the cube just ascended into the sky upon that? That is something that's also worth fixing. And yeah, let's fix that. To fix this up, to fix that issue where the enemy just floated into the sky, we gotta think of our mobs as being finite state machines. So the enemy object that we had, it was moving, but then it died, so it should stop moving. So here we need to think of the game object, the enemy, as being in one state at a time. So that first state should be a moving state, so it should be allowed to move. If it gets hit, it moves to a different state called died. So now that game object should be declared dead. It should not be allowed to move. This is a concept that you'll see a lot in computer science, and especially in AI. So in our case, we want a finite state machine for character movement. It should be allowed to move if it's in a state that is allowed to move, but it should stop moving if it is in a state where that is not, where it is not allowed to move. In this case, we want the simplest way to represent this, in our case, is with a single Boolean character that is true if alive and false if it's dead. So we have a two-state machine. There's only two states. The game object is either considered alive or it is dead. If it is alive, it's allowed to move. If it is dead, it should stop moving. Pretty simple. So this is the code that we're going to add to our state machine. And then we need to add another method after that. Let's start with these few lines of code here. Let us go back into our WanderingAI script. So remember how we were moving it forward every call of the update method? Well, we're going to add a bool here. So we're using a single Boolean value to represent the current state of our game object, either alive or dead. Oh yeah, we also need to put back our start method here. And we need to say, at the beginning of the game, this game object should be alive. And now, when we move forward, we can only move forward if this object is in the alive state. If it's not in the alive state, then it's considered dead. We are not allowed to move. So if is alive, we're gonna enclose this transform.translate method in curly brackets like that. There's an extra method that we need to add here. And this is a public method to set to alive by outside scripts. So it's a outside method. This method is going to be called by outside scripts, and it's going to pass in true or false depending on whether we want the game object to be alive or not. In this case, we want this game object to die when it's hit. So public void set alive bool alive is alive equals alive. If we pass in false, this kills the game object. That then triggers the death animation, but like that's separate. But once we set this thing to, when we set this from alive to not alive, it's gonna stop moving. There we go. In our ReactiveTarget script, okay, so here's what's going to happen. The ReactiveTarget script should have a reference to the WanderingAI script that is also attached to the same game object. So when we call react to hit, we get a reference to the WanderingAI script attached to the same game object. If that script is not null, we're going to call set alive and set that to false. We're going to call set alive and pass in false. So let me add some comments. So if the actually no, I need to do this first. WanderingAI behavior equals get component WanderingAI and that should be look at that. If behavior is not null, we say behavior dot set alive false. So here's what's gonna happen. So the enemy cube here has two scripts attached to it, ReactiveTarget and WanderingAI. ReactiveTarget and WanderingAI are two separate components. If the enemy cube here is hit, it's gonna react by, well, falling over and die. But it also has a WanderingAI script attached to it. Or, if we want a stationary object, it could be a whole different script entirely. Or, in this case, if we want to have a stationary object, say it's a turret, then WanderingAI would be pointless to have. It would just fall over and die as it normally would. But you can probably see the potential of mixing and matching scripts as needed. Though if you want even more flexibility, we might need to implement something called an interface. That's going to be a little bit later on in the course, by the way. My point is this. With these two scripts loosely coupled, we can mix and match. We can have objects, we can in theory have objects that can react to being hit, but they don't wander. Alternatively, we can have objects that can wander, but they don't react to being hit. Or they may have to react a different way. With the two scripts combined, well, placed under the same game object, if we hit the object, it's going to see if there's a WanderingAI script attached to it, and if there is, it's going to set that internal state machine for the WanderingAI from alive to not alive. That way, it'll stop moving when it falls over. Let's see that. We have the spinning cube over here from before. Let's... And now it's dead. There we go. One other thing to note, that this is a two-state machine here. If we want more complex behavior, we would need several states. We might need an entire state transition function as well. For that, we might need to add in several more scripts as well, such as a script for different types of movement, for example. But the point is, by splitting up the code this way, we can mix and match our scripts as needed. As I said, we could have a game object that can react to being hit but not move, and we could have an object that can move but not react to being hit. Or we could have a third script that could be, say, a turret. That turret rotates, and it could react to being hit, but it would only fire at things that it should fire at, say the player. The point is, writing our code this way makes for more flexible code where we can mix and match components as needed. So here's another thing we should look into doing as well. We're going to create a empty game object that's going to be a spawner. So this game object is going to spawn enemy objects. For this to work, we need to... Well, actually, before we even get to writing a spawner, we should make this into a prefab. So a prefab is a fully fleshed out game object with components attached to it that exists as its own asset, not specific to any scene. So An asset is any file that shows up in the project view here. So these are assets, scripts are assets, scenes are also assets, textures are assets, sound files are assets, 3D models are assets, and in this case, entire prefabs are assets. So let's create a brand new folder called prefabs. We also made a material here, so for organizational purposes, let's make a materials folder here. And just move that enemy material into there. We're gonna create an entire prefab for our enemy. So to make our enemy here into a prefab, all we gotta do is drag and drop it from the hierarchy into the project view. Notice how it's turned blue? Now, if we want, now we can make changes to this instance of the enemy prefab, but if you want to make changes that would affect every instance of the enemy prefab, you have to click this little button to the side here. Here, it's through here that we can edit the enemy prefab however we want. And those changes will affect every instance of the enemy game object. Well, I should say prefab. There we go. So now we have a prefab, and with that, what we can now do is put a bunch of these cubes into the scene. Okay, there's a little problem with that. They're all intersecting the ground a little bit, so I'm just gonna raise them up. And now if I play, look at them all go. They're just wandering around, and they're also smart enough to not collide into one another, too. Look at that. It's kind of hilarious to see these little cubes just wandering around, but they all have the same components attached to them, so if I just shoot them down like that, they fall over and die. Okay, now let's make a spawner. So I'm just gonna delete all of these game objects over here, and I'm just going to now create a brand new empty game object. Let's call it a SceneController. So this is a SceneController at position 000. I should probably move the player out of the way so there's plenty of room between it and the SceneController. So what we're going to do in the SceneController, well, obviously we're going to make another script for this. Let's call it SceneController. So, in the SceneController script, it's not open. Okay, now, in the SceneController script, we are gonna write even more code. So we're going to have a private field that we can serialize in the inspector. This way, this field, by placing serialized field like this, we can edit a field in the inspector, but it cannot be edited by any other game object's scripts. Okay, with that, we need so this way we can specify what prefab to spawn in the inspector, and no other code can change it. Here, we're going to have a private field that keeps track of a single instance of the enemy. So, private game object, enemy. In the update method, if there isn't an enemy, spawn one. If enemy equals null, okay, so if there isn't an enemy, then enemy, this variable here, is going to be null. In that case, we're going to instantiate a new game object, enemy equals instantiate prefab this should be called enemy prefab over here as game object. There we go. We are going to, oops, I need to take that out. I'm then going to set the location of this enemy prefab to be the location 0, 1, 0. So at the origin, but slightly above the origin. So yeah, at the origin, but 1 unit up from the origin. And that's because I made the cube 2 units tall. This is to give some clearance for the ground. And then I'm gonna rotate it at a random direction. So enemy dot transform that position equals new vector 3 0 1 0. And then we're gonna randomly rotate this enemy object. So what angle equals random.range 0 to 360 degrees. And then we're gonna say enemy transform dot rotate, and we're gonna rotate it up at the y-axis. So that is 0, angle 0. There we go. So let's go back to our scene, and let's check out that scene controller. Oh, because now we have a game object that can spawn new game objects, we don't really need this enemy game object in the scene anymore. So we can just delete it, because we already have it as a prefab. So this scene controller should have the scene controller script attached to it. See this empty field in the inspector here? We're gonna drag and drop our enemy prefab into that field. When we do, and we play this game, it's gonna spawn a single game object, enemy game object. I can shut it down. Like so, and when it dies, a new one spawns at its place. Pretty basic. Very simple, right? And because it is going to be moving in a random direction, a few of those were moving away, and then a few of the other ones were moving towards me. So, looking pretty fleshed out, don't you think? Okay, so here's where it's going to get a little bit more fun. We're gonna give the enemy prefab the ability to fire fireballs at the player. So, let's work on that. We're going to create another prefab. I'm just going to create a brand new game object that is a sphere. We're going to call that a fireball. I'm going to reset its transform so that it's in the middle like that. See how we have a fireball? Well, it doesn't look like a fireball now, but that's because we don't have the appropriate materials for that. What we're going to do next is we're going to create a brand new material, not unlike the enemy material that we had made previously. We're going to make a new material. Let's call it fireball material. Let's give it an appropriate red color, like that. So if you want 100 flames, it should be more orange. Let's go with something like that. There you go. So we'll attach this fireball material to our here. Maybe it's similar to the previous material we have made. Let's just make it a little more bright. There we go. Now, one other thing we can do is there is an emission option over here. If we check that checkbox, we now have another color field we can edit. This will make our object glow. There we go. So now we have a fireball. Let's then let's drag and drop this fireball into our prefabs folder here. So now we have a fireball. And now we have it as a prefab, we don't have to keep it in the scene like this anymore. So we can just delete that. If we need another, we can just place it into the scene. But we're gonna write some code that will place it into the scene for us. This fireball is gonna be created by the enemy prefab, and it's gonna move towards the player. Or at least that's the idea. Okay, so now we need to give our enemy prefab some more brains. So the enemy AI is smart enough to move around the scene, like to avoid obstacles, but it doesn't know what the player is yet, so we need to write a few more scripts for this. So remember when we were doing Raycasts, we have the ability to figure out what game object we had hit, but also we can find what components are attached to it. So if the enemy performs its SphereCast, it can call getComponent and see whether that object has a player script attached to it. If it finds that player script, the enemy is going to shoot a fireball at the player. So we're going to create a new script. That script is PlayerCharacter. We're going to do nothing to the script. Not yet, at least. We're going to attach this script to the player. So now the player has a PlayerCharacter script that does nothing for now. Let's go back to our WanderingAI script. We are going to make some changes to our WanderingAI script. So, we're going to create a new field, well, two new fields. One is for the fireball prefab we're going to shoot at the player. The other one is a private field that keeps track of the current instance of the current fireball. So, serialized field. Fireball prefab. Okay, so two fields. One is the game object that we want to instantiate. The other one is an instance of that game object. So, down in this code here, we're going to make some changes. So we need to get a reference to the game object that was hit by our SphereCast. That is hit.transform.gameObject. We're going to save that in this variable here called hitObject. And what we're going to do is this. Yeah, we're going to rewrite all our code here. If the object hit was the player, shoot a fireball at the player. Otherwise, if the object hit by our SphereCast was some other object and it's too close to the enemy, turn around. So that code now looks like this. If hit object dot get component player character So this expression here is actually going to evaluate the true, and if it does, we're going to shoot a fireball at the player. If we didn't... Okay, so it's coded so that the enemy can only ever shoot one fireball at a time. So if fireball equals null, there are several ways we can code this, but this is the most simple. This is a simple way of coding it. This is the most simplest way of coding it. Much like the SceneController, where there can only ever be one enemy at a time. Fireball. And this is the code, and this code is more or less the same as the enemy spawning code here. Fireball equals instantiate fireball prefab as game object. Fireball that transform front position equals transform point, and that is spelled wrong. Vector3.forward times 1.5f. And then fireball.transform.rotation equals transform.rotation. So, okay, so what this code does is it will spawn a single fireball right in front of the enemy prefab, but we also need to rotate it so that it is in the same rotation as the enemy prefab, so that way whichever direction the enemy was looking at, that is the direction that the fireball will also move. So it'll spawn the fireball in front of the enemy prefab in the same direction as the enemy was facing. So one more line of code here, and that is fireball.transform.rotation equals transform.rotation. So this is the rotation of the right hand side here. That is the rotation of the enemy game object. That is the same rotation as the fireball is going to have. So yeah. So this fireball is going to, as I said, spawn in front of the... it's going to spawn right in front of the enemy and move in the same direction as the enemy also. Okay, so this code here is also going to be here, so but that is else if. So if we hit the player with our SphereCast, we're gonna launch a fireball at the player. Otherwise, if this was any other game object in the scene, we're just gonna turn around some random rotation. So now, what we need to do is we need to edit the prefab in the inspector. So we need to edit the enemy prefab in the inspector. So if I just double click this, it'll open the enemy prefab in this blue scene here. This is the editing window for the prefab itself. Any changes we make here will affect every instance of the enemy. We have a field for our fireball. Let's drag and drop that fireball game object prefab into this slot here. So now, if I play the scene, if I exit that prefab view and play the scene, we see that the enemy is moving along, but if I get in its way, it's going to spawn a fireball and it's not moving. And that's because we did not write any scripts to get the fireball to move. So let's fix that up. Just in case the enemy is too high to see the player, what you need to do is change the height value of the... Okay, just in case the enemy can't... In case the enemy is way too high up to see the player, go into the SceneController. This is the code that spawns the enemy. In case the enemy is too high, just change this height value here accordingly. So let's go back and write a fireball script. So we're gonna write yet another script. This is fireball, and open up that script. We're gonna add two fields. Those are public float speed. Let's set that to 10F and damage. So it will deal 1 hit point of damage, and it will move at a speed of 10 meters per second. The start method, we're not going to do anything with that, but we are going to be using the update method here. So we're going to say transform.translate, and remember the z-axis is forward and backward. So we're not going to pass anything for the x or y components here. 0, 0, and then finally speed times time.delta time. There we go. Okay, so this fireball's gonna move, but it should despawn the moment it hits something. So here's what we're gonna write now. We're gonna add an OnTriggerEnter method. So this method is going to detect whether it had hit the player, and if it did, it's gonna, for now, it's gonna say I hit the player. Hey, so for clarification, OnTriggerEnter is invoked if the collider of a game object overlaps with the collider of another game object. So in the case of our fireball, if that fireball's collider intersects with the collider of some other game object, the fireball is gonna despawn. Okay? Alright. Other.get component PlayerCharacter. So if we hit an object, we're gonna check the collider to see if it has a PlayerCharacter component attached to it. If it does, we're gonna say we hit the player. gonna then say if player does not equal null, then debug.log player hit. But either way, regardless of what it had hit, it should destroy the game object. So we're gonna call destroy and pass in game object. So once again, game object, lowercase g game object by itself in a context such as this is referring to the game object that the fireball script is attached to. That means it's gonna destroy itself when it hits something. Alright? Okay, so now we have a script that we need to attach to the fireball prefab again. So go back to that prefabs folder, open up the fireball in this editor here. We need to drag and drop the fireball script onto the game object here. There we go. Now if we play the game and try to get in the way of the enemy, there may be a problem here. So the problem is, pause the scene so I can... Yeah, the fireball did not properly despawn. And you want to know why? We forgot to add another component. First, double check to make sure you have a sphere collider component attached to it, and if it is already attached to it, check this checkbox so is triggered true. The issue is this: the fireballs that are being shot by the enemy are facing through walls. Even if they contact the player, they might still face through walls. So to fix that issue, the component that we were missing is a rigid body component. Turn off use gravity, so that way, if we have this fireball colliding with anything, it will disappear. If it collides with a player, eventually we're going to deal damage to the player, but either way, it's going to disappear the moment it hits anything. So we need to make sure these two components are attached to the fireball and have the following settings as described here. So the first one is a sphere collider. Make sure its trigger is set to true. The second one is a rigid body. Make sure that is attached and use gravity is turned off. So those are the bugs we have to fix to make sure that when these fireballs are shot, they disappear properly. Okay. Let's try it. Okay, so what I'm going to do is spawn multiple instances of the enemy so that we have several in the same scene. This is for testing purposes. I want to get several enemies to try to fire at me. So the idea is that whenever they create a fireball, they're gonna, whatever they hit, it'll disappear. And if they hit me, the fireball's gonna say it hit me, the player. Alright, so now we have fixed that bug. We are not quite done yet. The last thing you should do is as follows. We are going to go back to the player once more. We had written a script called the PlayerCharacter script. There is nothing in it right now. So we're gonna populate that script with a few basic fields. So we're gonna give the player 5 health to start. And then we actually don't need the update method here. Instead, we want to add one more method, public void hurt in damage. So this method is going to be called by the fireball. It's going to use that reference to the player character component and call this hurt method to deal damage to the player. So health minus equals damage. So here damage is going to be a positive value to indicate we are dealing a positive amount of damage that should be decremented from the player. I guess negative damage would in theory heal the player. Negative damage. Think about that. Okay, and then finally we're gonna write a debug.log message here. And I'm gonna write it a little bit differently. I'm gonna start it with a $sign and then add quotation marks, health, colon, and then in curly brackets, the health variable. There we go. I'm gonna add a comment here, and that is this is the method to call to deal damage to the player. So in the fireball script, what I'm gonna do is, okay, so in the fireball script there is a field for damage. It's going to inflict 1 damage. So once we have this reference to the player character component, what we're gonna do is say player dot hurt. So this will hurt the player for however much damage this is. So 1 damage, or we'll just pass in the variable called damage. There we go. So when we play this game once more, and I'm gonna play it with multiple copies of the enemy just for testing purposes. This is to increase the chances that I get hit by a fireball. Okay, perfect. Now we can say our game is functionally complete. There are a few more things that are not in this game yet. As you can tell in the console, I'm at negative 36 health and counting. So, much like how these enemies are a state machine, we should probably add an option. Notice how I stopped that fireball in midair. I guess that's not a bug, that's a feature. Let's keep it. Okay. I can shoot down all these enemies. I can shoot down all these enemies, and there's gonna be, that's gonna whittle it down to that one enemy that is being referenced by the scene controller. The scene controller will always have one enemy to spawn. I don't know where that enemy is right now, but if we want to have a more complete game, one option we should have, one thing we should code in is the ability to count down how many enemies are left to kill. What would also be worth adding is the ability for the scene controller to randomize the location of, randomize where to spawn enemies. So one way to do this is to have a array of game objects, and they're all empty game objects. They could be empty game objects, but they could, for example, be empty game objects. The scene controller is gonna pick a random one and place an enemy at that empty game object's location. Another thing worth adding is a limit to how many enemies the scene controller should spawn, and if that counts down, let's say it's set to 20. So if the player successfully shoots down 20 enemies, game over, player wins. Yeah, so there is quite a lot we can do with the space game. And we haven't even talked about the fact that this is a rather boring scene. Plain white walls, the enemies are just primitives. The balls here are, they could be bullet holes. Yeah, there is a lot we can do with this scene as well, and we haven't even gotten to all of that. So, I guess I'll have to leave it here for now, and Chapter 4 is gonna be importing assets into the scene to make this first-person shooter a lot more interesting. Alright, I'm gonna end the video here, and I guess we'll have to, that's gonna be for next week. So we're gonna add assets to our scene, and there'll be textures, maybe 3D models. Yeah. Alright, take care, and I'll see you in the next video. Goodbye.